Hello, everyone. Welcome to the FHIR Path Library session, and I introduce Saman and Vaji.
Okay, good morning, everyone. My name is Saman, and here with my colleague Vaji, we are here to talk about this topic that is one of the challenges that we have been facing. As you can see, we tried to synchronize our t-shirt, but unfortunately, we didn't agree on the color. We should have done that. So yeah, we are both software engineers from Verily. We used to work at Google. Vaji specifically, he worked on the Cloud Healthcare API by GCP for a couple of years. Myself, I was in different projects for a couple of years, and then for the past 3 years, we have been working in Verily. So let's start with the problem statement. So basically, the problem that we encounter is this. We need to push new versions of Verily FHIR IG into production while ensuring that these updates do not cause any system failures. The primary challenge here is that due to business requirement and incremental software development, often we need to have backward incompatible changes to our existing profiles. Before we deploy these changes to production, we need to make sure that they do not cause any system failure or any disruption to our live traffic. This talk will focus on our experience in managing these updates, and we hope to learn from community and other members of FHIR community who have been facing this similar challenge in their day-to-day work. Okay, so let's get started and dive into and find out what are backward incompatible changes. We categorize them into two different groups. We call them strengthening changes and weakening changes. So strengthening changes are those that involve adding a new constraint to an existing profile. So let's say that we have a optional field and we modify it to be required. So usually these changes make profile more like stricter, and then it will cause like some of the resources to be rejected or not to conform to the profile. And then we have weakening changes, which is kind of the opposite of the first category. And then usually we remove some existing constraint from a profile. So again, you can imagine that we have a required field and we modify it to be optional. So here is like a simple example. Like imagine we have a patient profile at V1, the gender field is optional, and then due to some requirement, we modify it to required and at version 2. And then later, like let's say that this causes a bug or like our business requirements are changing and we modify this back into optional. So the first change here, like going from V1 to V2 is a strengthening change. And the second one from V2 to V3 is a weakening change. And then as you can see, there is this duality relationship between these two categories of backward incompatible changes. And here we try to summarize them in this table. So as you can see, we put all backward incompatible changes into 4 categories. Like there are some that are related to cardinality. There are some related to like limiting possible values that a field can have. Changes of reference type and invariance. I'm not going to go into details of all of like each of these backward incompatible changes, but as you can see, like any of these changes in the first column, the strengthening column, it will cause a profile to be stricter, and then any change in the second column, the weakening column, it will relax the profile. So before I go into details and explain how each of these categories of backward incompatible change might cause issues in the production systems, let me just quickly explain how at Verily we utilize implementation guides. So, you know, we have been hearing like a lot of talks in the past 2 years about profile validation. And then here what we call FHIR validation is what in the community is like known as profile validation. So imagine when we are persisting resources into our CDR, we check the conformance of the resources, and then if the resource does not conform to the profile, we reject it. Otherwise, we will persist it to the FHIR. So we call this hard validation. And then in addition to that, we implemented this second way to enforce or to to check the conformance of resources. We call it soft validation. And then this will happen asynchronously after a resource has persisted to the CDR. So basically, when we receive a resource, we will persist to the CDR regardless whether or not it conforms to the IG. And then later we have this validation service that asynchronously will crawl the CDR, and then it will check every resource to see whether or not they conform to the profile. So it has a couple of benefits. First of all, it will help with the performance. If there is a performance issue, as we heard yesterday, a couple of teams, they complained about that. Luckily, Healthcare API, we haven't noticed anything, thanks to our colleagues at Google. And also, another benefit of this soft validation is that we avoid losing data. Imagine that, we have front-end services that are writing resources to our CDR, and we cannot afford to lose those resources. So we will persist them to the CDR regardless of their conformance, and then later we can go ahead and tag them as test or fail, pass or fail, sorry. And then another thing that I would like to highlight here is that our colleagues at Verily, we recently open sourced a Golang implementation of FHIR path. Today there is a talk about this, so I'll encourage you to go and listen to that talk. So just quickly, here is just another, continuing on our example. Imagine we have two resources, patient 1 and patient 2. And in patient 1, we have a value for gender, and the patient 2 is missing a gender value. So what will happen after we persist these two resources into our FHIR store, the validation service is going to go and check the conformance of these two resources. For the P1, because it has all the required fields, it's going to add a tag to the resource as pass, which means that this resource has passed all the integrity checks, and then now all downstream processes can use this resource. While for the second resource, P2, because it is missing a required field, it will be tagged as fail, and then this will stop downstream analysis to use this resource, and then probably we need to go and somehow fix this resource, and then we can process it further down. So with that, I'm going to hand it over to Vaji, and then he's going to show you the consequences of these backward incompatible changes.
All right, we do have two main problems with the backward incompatible changes. The first one is about the data conformance, and the second one is about the software compatibility. Data conformance is happened because we often strengthening the IG, we added more constraint, and then some data might become inconsistent with the new version. This is not uncommon. IG is supposed to be more specific, so then we add more constraint to that. So it happens, and then we need to do, and then we need to detect that, and then somehow fix that. The second one is a more subtle. It happens when we weaken some constraint. We remove some constraint. The issue here is that the downstream systems, the developers usually make some assumption from the IG, and then when we remove those constraints and relax them, those assumptions are not hold anymore. So then the software was developed can produce some unpredictable result or even crash. And we want to make sure that we can detect them before we are making our production changes. All right. About the data conformance, I have an example here. So we can see that we have two patient profiles, V1 and V2, and then we strengthen the constraint on the gender from optional to the required. The data conformance is shown here in this example. For example, P1 and P2 both don't have a very good gender field, but they're still passing because the gender field is optional. But as soon as we upgrade our IG from V1 to V2, both to this valid patient become invalid. And then if we have not foreseen how to fix this, we might lose this data, and then downstream systems that rely on the correct data might ignore them. Our idea and solution for this is a concept of dark launch. Basically, before making our final launch, we put both two versions of the IG in our system, in the production system. The the production system relies on the current version, but at the same time, we use the traffic in production to test the future version. So this way, we make sure our system is robust, is working correctly. At the same time, we can detect any issue that we have not seen before that. And any change, for example, from pass to fail, could be detected, and then we can intervene and fix it before making the final call. Let's go back to our example here. We can see that, for example, we have 3 patients, 3 instances, and then 2 of them are passing. And once we update our IG, we are testing it against both 2 IGs, V1 and V2, and we store the result for both of them. But our downstream systems only rely on the V1 and ignore the second one. And our monitoring system detects any change from pass to fail, and then we can review it and then update our IG, our downstream systems, or any fix that is possible. What about the software compatibility? I have a very short code here, snippet. I mean, we have a service that calculates BMI for a patient. And so basically, this service, this function, expects that the patient to be valid with respect to the IG. So then it has a condition, and then based on the gender, it can do something. All right, for the V2, for the current version, the patient is failing because it doesn't have a gender field. All right, the patient is not passed, everything is good. But as soon as we go to V2 to V3, and then we make the gender field optional, there is no gender field. And then this if statement fails, and we need to somehow fix that, and then before our system crashing the production. What's our solution for this? We are making, for now we are relying on more testing. And we want to test whether our downstream system can tolerate the changes in IG. And these tests are instances of our resources that their profiles are changed. We have 2 properties. The first is that we want to make sure that these instances does not comply with the current version of the IG or the older version, but complies with the newer version of the IG. And having these instances, we can create a test suite, and then using this test suite, we constantly change our downstream systems after any IG changes. And if there is anything happen in the pre-production environment, we can detect them and then fix them. All right. We are still in the process of developing these ideas and then make our production releases more resilient. One of the issues that we have is that the dark launch is a good idea, but it's more like a safety net. It's not a best solution, at least from dev experience. It's at the very end of the dev cycle, and our feedback loop is very long. We have to release, deploy to dev environment, and then a pre-prod environment, and then after that prod, and then if anything happened, I mean, maybe a few weeks after the development, we can detect that and then fix it. We want to make sure that these issues are captured sooner. So we try to shift this test as soon as possible. Basically, if we can check them at the compile time, for example, this multiplicity checks could be checked at the compile time, or we have some unit tests, then integration test, and then we can have a better confidence on our launches. In terms of the quality of tests, these are manually crafted tests. We need to make sure the quality is good. They have a good code coverage, first of all. And also, we are working on some automated test generation. This way, we can input 2 IGs to to this test generator and then generate some test cases automatically without need for human to write those tests and then somehow make those tests bad. All right. Yes, I covered everything. Almost at time. Thanks for listening. We are here to answer any question.
We do have a few minutes for Q&A if anybody has questions.
In the period of time between you starting to take the kind of dark launch, assessing the degree of change, and starting to, I guess, work with your downstream apps to work around those changes, what would you say is the average time period it takes to start shifting over to the version 2 of whatever the new strength and requirements are? And are there things that can be done to help consolidate that time to make it easier for your developers?
So, like as Vaji said, this is like a new process. So for now, what we do when there is a new backward incompatible change, we just push it like from dev to test to stage and to prod. And we usually like leave them for at least a couple of days, make sure all our tests are running. So it takes, I would say, like about 2 weeks to go from like a backward incompatible change all the way to prod. And then that's one of the main problems of developers as well, because they make a change and they need to push it to prod faster. But again, we are hoping with like more automatic tests, having better like test coverage, we could reduce that time. But for now, that's what we do. That's our process.
All right. I think we're all done. Thank you.
Thanks, everyone.